Hello everyone. Uh, we are starting with the topic of differential equations. Okay. Now, differential equation is an equation which has various differentials. Differential equation is an equation which has various differentials. Okay. The differentials. When I say differentials, it means dy by dx. That is the first order derivative. Okay. It can also be d square y by dx square. It can also be d cube y by dx cube. It can also be the fourth order derivative of y. So these are differentials. So an equation which has all these differentials are called as is called as a differential equation. Okay. Now the first and foremost we need to understand the order and degree of a differential equation. Fine. So let us take some examples of order and degree of a differential equation. Okay. Now let's take an example. First example. So the first example has d square x upon dt square plus dx by dt the whole square plus 8 equal to 0. Okay. Now this is a differential equation. Why this is a differential equation is because there are two differentials present over here. The first differential is d square x upon dt square, and the second differential is dx upon dt. So there are two differentials. Okay. Hence it is a differential equation. So the maximum order, the order of the first differential is 2 and the order of the second differential is 1. So this part is first order derivative. Okay, right? And this part is the second order derivative. Okay, so 1 and 2 represents the order. So order is nothing but the maximum order of the differential in the equation. So the maximum order is 2. So the order of the differential equation is 2, right? So we are having two differentials once again, that is dx by dt and d square x upon dt square. But then the maximum order is 2. Hence the order of the differential equation becomes 2. Now degree is the power of the maximum order. Okay. So maximum order is d square x upon dt square. So the power of this is 1. Okay. So the degree becomes 1. Right. This was the first example. Let's take some more examples. Right. Second example, d square y upon dx square the whole raised to 2 plus dy by dx the whole raised to 2 is equal to a raised to x. Now let us first note down the different differentials in this problem. So the first differential is dy by dx. Okay, dy by dx, that is the first order derivative of y. And the second differential is d square y by dx square. D square y by dx square. So d square y upon dx square. So here the order is 1 and in the second the maximum order is 2. So the order of the differential equation becomes 2. That is the maximum order. Okay. So the order of the differential equation is 2. Now once we are sure about the order, go to that particular differential d square y by dx square. The power of it is 2. The power of it is 2. So the degree becomes 2. So the order of this differential equation is 2 and the degree is also 2. Next example, d raised to 4y upon dx raised to 4, the fourth order derivative. Okay. plus 1 plus dy by dx the whole square cube is equal to 0. Let us note down the different differential equations, differentials. So the first differential is dy by dx. The second differential is d raised to 4y upon dx raised to 4. Okay, so the order of the first differential is 1, the order of the second differential is 4. So order of this differential equation becomes 4, this one. Okay, and degree. Okay, so go to the differential equation d raised to 4y upon dx raised to 4. So it's over here. The power of this is 1. So the degree becomes 1. Fine. I hope you are understanding what is order and degree. Next one. Y triple dash square plus 2 into y double dash square plus 6y dash plus 7y is equal to 0. So let us understand the different differentials in this problem. So the first differential is y dash. Second differential is y double dash. The third differential is y triple dash. Okay, so the order of the first differential is 1, order of the second differential is 2, order of the third differential is 3. Okay, so the order of this differential equation is 3. Order of this differential equation is 3 because it has the maximum order over there, 3. Okay, now let's highlight that differential equation. It is differential, that is y triple dash. The power of this is 2. Power of this is 2, so degree is 2. Okay, so degree is nothing but the power of the maximum order, the power of the maximum order. So in this case, the power of the maximum order is y triple dash, that is 3. Okay, order is 3, so power of it is 2, so hence the degree of this differential equation becomes 2. Okay, now one thing we need to get very clear: the differential equation, while finding out the order and degree, we need to make sure there are no fractional indices. The power should not be in fraction, there shouldn't be any fractional index, and at the same time there shouldn't be any negative index. Okay, so let's take some example of that particular category. Okay, so root of 1 plus 1 upon dy by dx the whole square is equal to dy by dx the whole raised to 3 by 2. Now here, as you can see, there is a fractional index, there is a root over here. Root indicates 1 upon 2, right? And there is a fractional index over here also, 3 by 2. So we'll have to eliminate this first. So what we'll do is we'll square both the sides. To eliminate the root, we'll square both the sides. 1 plus 1 upon dy by dx the whole square is equal to dy by dx raised to 3 by 2. We'll square both the sides. We'll square on the left hand side, we'll square on the right hand side. Okay, what will happen on the left hand side is the root and square will get eliminated, and on the right hand side this 2 and this 2 will get cancelled out. Okay, because we are squaring. So eventually we are left with 1 plus 1 upon dy by dx the whole square equal to dy by dx the whole cube. Dy by dx the whole cube. Now we need to simplify this further. We cannot just blindly write anything. Okay, take LCM over here. Dy by dx the whole square plus 1 upon dy by dx the whole square is equal to dy by dx the whole cube. still the simplification has not been completed. So shift this over there on the right hand side. So dy by dx, the whole square plus 1 is equal to dy by dx. Okay. If we multiply, these two terms, this over here, okay, so it will be something like this, right? Then apply indices on the right hand side. Just apply indices on the right hand side. Dy by dx, the whole square plus 1 is equal to dy by dx, the whole raised to 3 and 2 will get added. Laws of indices, a raised to m into a raised to n is equal to a raised to m plus n. Okay, so this is the final thing that we get, the most simplified format. Now try to understand what are the differentials. The differentials are only one, that is dy by dx. That is the only differential present in the entire problem, dy by dx. This is the differential which is present. Okay, so the order naturally will become 1 because there is only first order derivative. Okay, and the degree, what is the maximum degree of dy by dx? See, there are two degrees in the problem. At one end the degree of dy by dx is 2, at the other end the degree of dy by dx is 5. So the degree of dy by dx will consider as 5 because we are checking out for the maximum degree. So this is the order and degree for the entire problem, right? Then we'll proceed. Let's take some more examples. Dy by dx is equal to 7 d square y upon dx square. 7 d square y upon dx square. This is your question. It's in a simplified manner. Let us note down the differentials. So the differentials are dy by dx and d square y by dx square. These are the differentials. So this is the first order derivative and the second order derivative. So the order of this differential equation is 2. We have to consider the maximum order. And degree. When I say degree, we'll go back to the place where we can see d square y by dx square, where we can see d square y by dx square. Okay, because it has the maximum order. So it's over here. Now try to understand, the power of this entire thing is 1. So the degree becomes 1. Okay. Next example, d cube y upon dx cube is equal to 9. D cube y by dx cube, the whole raised to 1 by 6. The whole raised to 1 by 6 is equal to 9. As I said earlier, we don't require a fractional index, that is a fractional power, okay, or a negative power in the index, right? Fractional indices and the negative indices are not allowed. If they occur, then we need to simplify this further. So now this is 1 by 6. So taking sixth power on both the sides, okay, because there is 6 down. So d cube y by dx cube, right, raised to 1 by 6, the whole raised to 6 is equal to 9 raised to 6. So I'm taking sixth power on both the sides. So this 6 and this 6 will get cancelled on the left hand side, and we'll be left with d cube y upon dx cube, d cube y upon dx cube is equal to 9 raised to 6, right? Now this is the simplified version. Okay, what you're supposed to do is you're supposed to find out the differentials. So there is only one differential present in the problem, d cube y by dx cube. Order of this is 3. So naturally the order of the differential equation is 3, okay, because it is the only differential present in the problem. And at the same time, when we look at the third order derivative, its power is 1. So the degree becomes 1. Fine. Okay. Some more examples. Okay, so just a second. Okay, so let's take one more example. Dy by dx the whole cube minus d cube y upon dx cube, okay, plus y into e raised to x is equal to 0. This is the differential equation. So we'll write down the differentials present in the problem. So dy by dx is one of the differential present in the problem. Then again d cube y upon dx cube is the other differential present in the problem. Okay, so we are having the first order derivative, we are having the third order derivative. So the order of the differential equation is 3 because 3 is the maximum order in the problem. Okay, now when we take a look at the third order derivative, its power is 1, so the degree becomes 1. So the order is 3 and degree is 1, right? Okay, next example. 1 plus dy by dx the whole cube raised to 2 by 3 equal to 8 d cube y by dx cube, 8 d cube y by dx cube. Now as we have discussed earlier, there shouldn't be any fractional index over here. Okay, so what we'll do is we'll take third power on both the sides, or we'll cube both the sides to eliminate this 3. So cubing, if we take the cube of, just cube on both the sides. So by cubing, this will be the whole raised to 2 by 3 into 3. So we have cubed d cube y by dx cube raised to 3, right? Now what will happen is this 3 and this 3 will get cancelled. So what we are left with? We are left with 1 plus dy by dx the whole cube, the whole raised to square. Okay, so left hand side is this 1 plus dy by dx the whole cube, the whole raised to 2. Then right hand side, okay, so 8 will also get a cube over here because 8 is also supposed to get cubed. So 8 cube into dy by dx d cube y by dx cube the whole cube, that is the right hand side. 8 cube d cube y by dx cube the whole cube. Now this is the simplified form. You can take a plus b the whole square on the left hand side. You can take a plus b the whole square on the left hand side, but then it does not matter as such. So look at the differential equation. There are two differentials, dy by dx, d cube y by dx cube. So this is the first order derivative, this is the third order derivative. So the order of the differential equation is 3. It has to be the maximum order out of the two. So 3, right? Then go to d cube y by dx cube. Okay, the power of d cube y upon dx cube, the overall power is 3, right? So degree of this differential equation becomes 3. Fine. Let's take a few more examples to understand this more into detail. Okay, so just a second. Yes, so d cube y upon dx cube plus x the whole raised to 3 by 2 is equal to d square y by dx square, right? Now see, This also has a fractional index, so we have to eliminate this too. We have to eliminate this too. So to eliminate this too, we have to take second power on both the sides, or simply squaring both the sides. So when we square d cube y by dx cube plus x raised to 3 by 2 raised to 2 is equal to d square y by dx square raised to 2. We have squared both the sides, so this 2 and 2 is getting cancelled, okay, as per laws of indices. So what we are left with? We are left with just check here, okay. So what we are left with? We are left with only d cube y upon dx cube plus x the whole cube, d cube y dx cube plus x the whole cube equal to d square y by dx square the whole square, d square y by dx square the whole square. Fine. So further, we can also take a plus b the whole cube on the left hand side, but then that is not really needed, okay, because there is no fractional index now. Fractional index as in the power should not have a fraction. So 3 and 2 does not have a fraction in it. Those are positive integers, okay. So let us note down the differentials. So the differentials are d square y by dx square and d cube y by dx cube, right? So this is the second order derivative, and we are also having the third order derivative. So there are two orders in the problem, second order derivative and third order. So the maximum order is 3 and maximum degree, okay. Now look at this, the maximum order is over here, the power of this maximum order is 3, so the degree becomes 3, right? Overall power of the third order derivative is 3, so the degree becomes 3. Fine. So one more example. X plus dy by dx is equal to 1 plus dy by dx the whole square. So there is only one differential present in the problem, that is dy by dx. Its order is 1. So the order becomes 1 and the degree. Now I'll highlight wherever there is dy by dx. So there are two dy by dx terms. Okay. The first one has a power 1. The first one has a power 1 and the second one has a power 2. So degree is the maximum power. So we'll consider the degree as 2. Okay. Fine. So that is how it is, the first topic of differential equations, that is order and degree. Fine.